a new chapter, relation and functions. But to proceed further, we should understand this concept, Cartesian product of sets. To explain you the product, Cartesian product, I will take some example. Let's say A equal to 1 2 and capital B is small a small b. Now A cross B, this is called the Cartesian product of A and B. So this is written as symbolically A cross B. So how it is to be written? Then we take first element 1 and we take this A. So 1 comma A, then 1, this is 1 comma B. I'm taking all possible orders. So this is 2 comma A and this will be now 2 comma B. So you can see that A cross B, actually how many number of elements have come? There are 1 2 3 4. The Cartesian product of two sets is also, you can say that the elements are of the ordered form. Ordered form means the first element is belonging to A and the second element is belonging to B. And ordered pair means, because you can see the elements of A cross B are written this way. This is the ordered pair. We say this is the ordered pair. So in general we can write the definition of also of Cartesian product. See the Cartesian product definition, you can write this, that's A cross B as elements x comma y, where x belongs to A and y belongs to B. So this is the standard definition of A cross B. If we can take some more example also to clarify its how we write the Cartesian product. So we take another example. Let's say we take P as M comma N, and we take Q, capital Q, as, let's say this is X, Y and Z. If I have to write PQ, then P cross Q will be written as, first one will be M X, then you can write M Y, then you can write M Z, and you can write this then N X, then N Y, and last N Z. So this is how you can write the product of P and Q. But you can also see that Q cross P will be, first you have to take the element of Q. So this is XM, XN, then YM, YN, ZM and ZN. So now you can see that P cross Q and Q cross P, they are not same. You can see that P cross Q and Q cross P are not same, because the order of the this has been changed. This was basically for P. Now this has at in Q cross P, this first element is belonging to Q and second element is belonging to P. So it means in general we cannot say that P cross Q equal to Q cross P. So this is not possible. Now let's discuss something more also, very important thing. You see in first example that A, number of elements in A is 1 2 and number of elements in B also 2. This is number of elements in A 2 and number of elements in B is also 2. And when we see how many elements are there in A cross B, you can see that there are 4 elements. So try to understand the relationship of number of elements of A cross B with number of elements in A and number of elements in B. You can see some another example. In P, you can see the number of element in P is 2 and number of element in Q is 3 and number of elements in P cross Q are 6. So we can write a general formula to find number of elements in P cross Q. P cross Q will be number of elements in P into number of elements in Q. So similarly here also you can see that number of element in A cross B is 4. So number of element in A is 2 and number of element in B is 2. So that's why this number of element in A cross B is 4. So this is the general formula that you have to keep in mind. Now we discuss exercise 2.1, which is based on the Cartesian product of two sets. The first question is very basic that you have done in class 10th also. X upon 3 plus 1, y minus 2 upon 3 is equal to 5 by 3, 1 by 3. You have to find the value of x and y. So simply you will equate the numbers 5 by 3. So from here you are going to get this cancels, so x is going to be 2, and for y minus 2 by 3 you put this is equal to 1 by 3. You simplify this, so 3y minus 2 upon 3 equal to 1 by 3. So 3 got cancelled, so y will be 1. You do the simplification, you will get these values. This question number 2 is based on this important observation that we did in when we were discussing the Cartesian product of sets. So this number of element in P cross Q will be number of element in P and into number of element in Q. So now this question number 2, it's given that number of elements in A is 3 and number of element in B is, you can see yourself, number of element in B is 3, 4, 5. There are 3 elements. Find the number of elements in A cross P. So according to the formula, number of element in A cross B will be number of element in A into number of element in B. So number of element in A is 3. This is 3 given, and this is also 3. So it means total number of element in A cross B will be 9. Now you see this question, G is 7, 8 and H has 5, 4, 2 as the element. We have to find G cross H. So I am finding G cross H and you will be finding H cross G yourself. H cross G will take first element of G as 7. So 7 can have ordered pair with 5. So 7, 5, then 7, 4, and it can be written as 7, 2. And next element you take, this is 8, 5, 8, 4, and lastly you can write 8, 2. So you can see these, this way we can write the set of G cross H. So H cross G, you can write yourself also. H cross G, you have to change the order of these also. So okay, so I'm writing for you this time. This is 5, 7. You change the order. This is, that's it, 4, 7 and 2, 7, then 5, 8 and 4, 8. This is 2, 8. And we have also discussed that G cross H is not equal to H cross G. So this general observation you can make. Now come to question number 5, in which A is given -1, 1, and you have to find A cross A cross A. So this is the Cartesian product of 3 sets. But how it is to be written? We first find A cross A. So A cross A is simply, you can write that way, that in 2 ways. This is -1 into 1 into, this is -1 into 1. So if you do like this, it's easy for you to understand how to write this. You take -1 and along with -1 you will take first -1 and -1 with -1, -1. First we have to make fix the first number, then 1. So you have completed -1 with these two. Now take the second one of this. This is 1 and -1 is 1 and 1. So you can see there are now 4 elements. Lastly, we have to find that A cross A cross A. So writing that in now with this black, this A cross A you have already written. So we have to see, along with, you just take the product of like this two again. So for symbolically you can see yourself how to do that. So now this time this will not be the ordered pair, there will be 3 element in in each bracket. So first you take -1, and this you take with this -1 combination. So this is the first element, -1, -1, second one is 1. So this is next one, -1, 1, this is -1, then -1, I'm taking this 1 and with 1, and next third you take this 1, -1, -1, and 1, -1 and 1. Next one is 1, 1 and -1, and last will be 1, 1, 1. So now you can count the number of elements in triple A. 1 2 3 4 5 6 7 8 and 8, because now order of this you can see A cross A cross A will have 8 elements, 2 into 2 into 2. I can explain you this again. You see how to write this. This is your A cross A. So A cross A, this element you take the combination with this -1 first. So your first element will be -1 and this is the -1. You keep it fixed first, then you take with 1. So this -1 and 1. So now you have taken this first and you have taken all two combinations with this A. This is A actually. This is your A. So now you have taken the combination. Now take this second one. This is -1, 1. You take this with -1 first. So -1, you can see this -1, 1 and this is -1. Next one will be -1, 1 and you take this one but with 1. So this way you take with all these 4 elements and you multiply with these 2 elements. So 4 into 2 will be 8. Okay, those who understood this product of 2, they can understand this question very well. As per the definition of Cartesian product, the first element always belongs to A and second element will always be belonging to B. So we have to write A and B separately. So you can see this Cartesian product, the first element will always be belonging to A. So this is A. Here it is A again, so we cannot write again. This is B, so we can write this B, here B. So it's again, we cannot repeat. So now capital B, the second element which is X belong to B, Y which is also belongs to B, and XY again repeating. So we cannot repeat the elements. So A and B, you can see they have been found, and 2 into 2, this is 4, and you can see the 4 element also in A cross B. So this way you can separate the element of A and B if it's given the product of 2 sets. Now see this question number 7. A is 1, 2, B is 1, 2, 3, 4, C is 5, 6 and D is 5, 6, 7, 8. You have to verify that A cross B intersection C is equal to A cross B intersection A cross C. And second part is that you have to see that A cross C, A cross B is a subset of B cross D. So we A cross B will take this, we will make it clear. So your second part is exactly A cross C is a subset of B cross D. So we have to find all the sets one by one. Means first we'll take A cross B. So A cross B, you see how to write A cross B. This is 1, 1, 1, 2, 1, 3, 1, 4, and then 2, 1, 2, 2, 2, 3 and 2, 4. This is the this is A cross B. We have to find A cross C also. So A cross C, you see now C has 5, 6 elements. So this will be 1, 5, 1, 6, 2, 5, 2, 6. So this is A cross C has been found. Now we will find B cross D also, because we need B cross D also. So B cross D, you can see now B has 1, 2, 3, 4 and D has 5, 6, 7, 8. So we'll take 1, 5, 1, 6, 1, 7, 1, 8, and next will be 2, 5, 2, 6, 2, 7, 2, 8. Third will be 3, 5, 3, 3, 6, 3, 7, 3, 8. Last will be 4, 5, 4, 6, 4, 7 and 4, 8. So in total there has to be 16 elements. So you can see there are 16 elements. So now we can answer this first part. The first part is A cross B intersection C. So this will find LHS. A means your A cross B intersection C. So A has, you can see the element 1, 2 cross B intersection C. So this is B and this is C. So you can see there is nothing common. So it is phi. So if there is nothing common, now you cannot make the ordered pair because there is no element. So answer of this will be phi. Now we take the RHS. RHS is A cross B intersection A cross C. Now you can check A cross B. This is A cross B and this is A cross C. So there is nothing common in these two sets. So again it is phi. So you can see that LHS equal to RHS, hence verified. Next one, that second part is asking that A cross C is a subset of B cross D. So this is A cross C 1 5 1 6 2 5 2 6. Can you see 1 5 here? Yes, it's there. 1 6 is there. Can you see 2 5? Yes, 2 5 is there. Can you see 2 6? Yes, 2 6 is there. So we can say yes, A cross C is a subset of B cross D. I make this little bigger so that you can differentiate between this capital C and this contain sign. So A cross C contain in B cross D, or you can say that A cross C is a subset of B cross D.